component, not all of it, but some of it, gets filtered off with a number of products that are still in really great condition that are usable. A lot of mineralization, the electrolytes, some of the hormones, some of the protein-based components. So we want to make sure that those get recycled, okay? This is what the renal corpuscle looks like. You have to know this. It will be on the lab exam, it will be on the lecture exam. This is the filtration device. Blood is delivered through this guy right here. Remember, we said that afferents arrive. So the blood that is arriving through that renal artery, and the breakdown of all of those, the interlobulars, the arcuates, the segmentals, all the way to the cortex where this nephron resides. Afferent arriving blood. And I'm going to show you what the inside of this looks like in just a minute. Blood is then pushed through because of the hydrostatic pressure through these structures right here, in which the filtration slit's too large to allow those blood cells out. However, things that are smaller being pushed out the posterior side, and you'll see these little black arrows. Little black arrows indicate the flow of the filtrate. The filtrate is the plasma-based portion that we're now going to go through and remove waste from, okay? So here's the filtrate coming off of the posterior side into the capsule, and I'll show you another picture here in just a minute. But the filtrate, blood coming through, plasma being separated off as filtrate, and then exiting through this guy right here called the proximal convoluted tubule. Proximal means closest to. So this is the part of the tube that's closest to the glomerulus. Convoluted means twisting and turning. Why? It creates a pressurization and a flow that allows for the reabsorption of certain types of material out of that filtrate. We also need to talk about this guy right here called the glomerular capsule. This is the capsule that lays over the top of or encases the glomerulus, because the glomerulus is actually the capillary bed underneath. The glomerular capsule is the encasement that provides the filtration slits and catches the filtrate once it's produced. Okay, in a minute we're going to talk about what are called podocytes. And the podocytes have little foot-like processes that create the size of the filtration device. Again, let me see. All right, it's not right there. I do want to talk about the podocytes. There's a picture a little bit later in our presentation. Think of it this way. The podocytes are little cells that have flattened feet on them. And when they place their flattened feet into this renal corpuscle, it creates little slits in between each of the feet. We all love to go to parades, and I love to pick on the Elmira Parade just a little bit because it's I appreciate the fact that people are still out there doing it, but sometimes when you look at what's going on at the parade, wow. But anytime you go to a public event in which you have large numbers of people, you generally also have a lot of traffic with vehicles, right? How do people get there? Well, we don't want those vehicles down in the middle of our parade. So what do? We take out concrete barriers and we put them in the roadways leading into the areas where our parade is going to progress down through. Putting out those concrete barriers creates a type of filtration device in which individual people can walk through those barriers and get to a parade route. Excuse me. But it prevents larger objects like vehicles from actually getting onto that parade route. Therefore, we have created our own type of filtration device by putting out concrete barriers in the middle of the roadways. Think of the podocytes as those concrete barriers, regulating the size of materials that can be pushed out of the glomerulus and into that renal capsule. Things, and I'm going to show you a picture in just a few minutes, things of certain sizes absolutely cannot get out of that glomerulus. And so what happens is blood coming in, run through these filtration devices right here with the podocytes. The fluid-based material with small solutes can get out to become that filtrate that then we're going to continue to filter on our way down through. However, the larger components with white blood cells, red blood cells, some of the larger proteins cannot get out of that glomerulus. So what happens to them? They don't just stay there, right? See this guy right here? The efferent arteriole, the exit for what has not been drawn off as filtrate and put back into the blood vesseling system. Okay, so blood in through the afferent, and look, see how much bigger this is? Why? Number one, hydrostatic pressure pushing, more blood volume, but we're going to separate off a fair amount of that volume in this structure. Therefore, what's coming out the other side, we don't need as much volume to take care of the exiting of that blood component. Okay, so afferent arriving, efferent exiting, much larger on the afferent arteriole because of the blood volume and the hydrostatic pressure coming out of the efferent arteriole. And you'll see on your on this particular visual, these efferent arterioles actually are in purple because it indicates that we have now left a portion of that filtrate in that renal corpuscle. And so the efferent arteriole, and also there is some delivery of oxygen and nutrient to that glomerulus, right? It needs to be fed. Let's talk about, and I'm going to transfer over to the board. I've got to change the lights up just a little bit and grab a couple of pens. So what we'll do is we'll take a quick little break. I will come back, I will throw this up on the board, and then we'll finish out the rest of the presentation.